everyone, welcome to another video where today it will be a little bit different. It's not a video on a new topic, it's a follow-up actually, specifically for Pitch Lumin, where in one of my last videos that was addressed to him, specifically this one, where we talk about the eclipse and what in my opinion is a misunderstanding of how we think eclipses happen. I've had a nice chat with Pitch Lumin in the comments, and I think that there are some things that aren't exactly clear. This is partially due to just explaining something in text is somewhat difficult, as well as my initial drawing in the video not being exactly the greatest help here. So I would like to try and now convey what I mean, or what I meant in the original video, a bit clearer with a second video. So here we are back at the OneNote notebook, where I'll try to explain what I meant in the original drawing, maybe a bit better here, right? So the red moon. Why is the moon red? We had a bit of a disagreement in the comments where it is unclear how the moon can be somewhere where you wouldn't typically see the red sky in the evening or in the morning, right? That's because there are fundamental differences in why you see red, right? That actually have the same origin though, so it's not completely unrelated. So let's say you are here, somewhere on a globe. Of course, I'm explaining the globe side of things, right? So you're here and you see about this far. Again, this is not to scale. It's just me, trying to make a better depiction. And you see about this far. So usually when you would see the red sky in the evening or in the morning, you would see it somewhere around here, right? That's because, and I will explain this later, the more direct you have of a line with the sun, the redder it gets, right? And this is also the reason why the moon seems red. Let's say we have the Earth. There's a day side and a night side. Sunlight comes in, touches the atmosphere here. Again, not to scale. The sunlight goes through the atmosphere here, and what happens when sunlight hits the atmosphere is, because sunlight is composed of many different wavelengths of light, right? So you have red light that comes in at more towards like 600 nanometers, a bit beyond that 700 nanometers. On the other hand, you have blue light that's at like 350 nanometers, that range, right? Because scattering of light in our atmosphere is so highly wavelength dependent, blue light will scatter all over the place. That's also the reason for why the sky is blue, because the blue light is so non-directional, right, that it will scatter all over the atmosphere and hit you from all kind of different angles, while the red and most of the yellow and green components of the sunlight will just go straight. And overall, the blue light is filtered out, most of the green light is filtered out, and just some yellow and a lot of red will go on. The Earth's atmosphere here is bending the light a bit due to refraction. This refracted part can hit the moon and then is reflected back. Now with reflection, the most efficient reflections on a surface like the moon will happen straight back from where it came from, right? So right here you will see the moon the reddest. But if you go over to where you are, you would still see a bit of red on the moon. Not to mention the Earth's shadow, right? But you also see a bit of a red shimmer. And this is why you can see the moon where there's no, like, high up in the sky, even though there's no evening red on the horizon. That's because the red from the moon that you see when there's an eclipse, it's not the same red that you might experience the moon as when you see it like in the evening or in the morning. So what you see in the evening is for another reason, right? You have a sunlight, and it's very straight, and here the sky looks reddish. That's because it's being scattered a bit, sometimes of clouds. Depends a bit on the environmental conditions, with how much water's in the air and things like that. And the rest of the sky will seem bluish to you and will get dark, and at the other side as the sun goes down. But that's not the reason why you see it, right? This happens, as I mentioned earlier, because on air molecules and aerosols, blue light scatters a lot better than red light. So red light more or less just travels on, and the blue light is scattered a lot. That's again why the sky is blue. Here's the formula if you're interested, and you can see here that there's a dependence on 1 over the wavelength of light to the 4th power, right? It comes from this term here. So you don't see a red moon because of the red you see at sunset during an eclipse. That, what I draw here, is not why you see the moon as red in an eclipse. That's why you see it red when it rises or sets sometimes, right? And that's also the explanation for why you see at sunset or at dawn sometimes red sky, right? This is the explanation for that, but that's not why the moon seems red during an eclipse. The moon seems red during an eclipse because Earth's atmosphere refracts the light to the moon, specifically the red part, since the blue parts are being scattered in the atmosphere. This hits the moon and comes back to you, the observer, who can be at any arbitrary position on the night side with, and that's I don't know how strong this effect is, right? It would be strongest if you stood somewhat close to where the original ray of light touched the atmosphere. If you were closer to that, I imagine it would be redder because of how reflection works. But it could technically be on any part in the sky. I have actually a picture that will be the thumbnail of this video if I can remember. Where you can see that the moon is not red during an eclipse at the lowest points, right? Okay, so Pitch, please let me know, Pitch Lumin, in the comment section or with a video or something, if that is more clear, if that clears up what you mean. And if not, I'm sure we can have another chat in the comments about it. But yeah, so that may be a useful clarification. All right, and that was it already in quotation marks. So yeah, I hope you enjoyed this very brief video, and I'll see you in the next one. Goodbye.